and welcome to Thursday's edition of Cracking the Cryptic. And after yesterday's shenanigans with colours, more on that in a moment, we might have more colouring to do, I think, for this puzzle, which is called Snakes on a Plane, and it's by Dying Flutchman, who's appeared on the channel a few times before, always with magnificent puzzles. So we should be in for a treat today, although this one does come with a recommendation from Mark. Never a thing to be delighted about, to be honest, because that might mean these snakes are deadly. We shall see. But I was tickled pink, actually, with this, which we were sent earlier on, to do with yesterday's solve, which is Faith Arise. She has drawn a picture of what it might have been like had I done that puzzle using felt tip pens rather than my computer, and I have to say that is so cool. I love things like that, so thank you very much, Faith. As I say, very tickled. Now, what else do I want to mention before I get onto the rules of Dying Flutchman's puzzle? We have more stuff on Patreon today. Mark has posted his solve of a recent Matt Gaffney American crossword. Now, those crosswords, in my opinion, are completely mad. Well, the crosswords aren't completely mad, but they all involve a meta at the end. You have to basically find a clever trick in the grid. Normally leads to a word or words, and these sometimes are completely and utterly mental. Anyway, this one is, I wouldn't say it's mental, it's fine, this one, but it's quite amusing watching Mark try and get something that I suspect many of you will get instantly. So check that out if you're a patron of the channel. Well worth looking at. Also, of course, we've got Scott Strossal's Sudoku challenge over there. More correct entries coming in on that all the time. Incredible. And Tantan Dai's solve of Glum Hippo's average arrows puzzle. Worth having a look at as well. Now, here are the rules of Dying Flutchman's puzzle. We have got normal Sudoku rules apply. Hooray! The grid is completely covered by 17 killer snakes. One snake of length 9 and 2 snakes each of length 1 through 8. Okay, well that makes sense, because if you add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, you get 36. So 2 lots of 36 plus a 9 length snake does equal 81, and the Sudoku grid sits in a 9 by 9 grid that has 81 cells, so that does make sense. A snake is 1 cell wide and has exactly 1 single bend somewhere along its length, except the 1 and 2 length snakes. Oh, I suppose they can't bend, can they? Okay, right, fine. Numbers don't repeat within a snake. Good. The 9 given numbers in the corners, yes, give the total sum of digits in the snake that occupies that cell. These killer clues apply to 9 differently sized snakes. 1, 2, 3, 4, 5, 6. Okay. Okay, so we've got, and that's the 9 length snake, obviously, because, well, as you know, if you watch the channel and you've shared my secret, if you add up 9 different digits, you get the number 45, if those numbers are the numbers 1 to 9 inclusive. Find the snakes and solve the Sudoku. Okay. As a bonus, use only 3 colours to colour the grid. No. We're not interested in your trichroic bobbins here, Dying Flutchman. We want chromatic festivals, as Faith Arise was keen to show us. So I'm not going to use only 3 colours, primarily because I get it wrong if I tried to do it. But you know me. I like my colours. So do have a go at this. The way to play is to click the link under the video. I've no clue how difficult this is, except it comes with a good lift recommendation. So it might be very hard. We shall see. Let's get cracking. Now, I can do Sudoku. I was just thinking, actually, how strange it is for me to have given digits in a grid. And I've got lots of given digits. I can write a 9 in straight away. I'm going to start with some Sudoku. This is very unusual. It's probably not going to do anything, but at least I got a digit there, look. 6, 7 and 8 into those cells. No, okay. It's petered out quite... Oh no, there's a 5 in one of these 2 squares. Right, okay, so we are going to have to think about the snakes. I'm not wholly surprised about that. We know that this is the 9-cell snake. Not sure whether it's better to start with the high snakes or the low snakes. The low snakes, yeah, the 3 and the 5 down here, these can't be 3-cell snakes, because a 3-cell snake, if all the digits are different, would have to add up to a minimum of 6. 1 plus 2 plus 3. So these are, oh, I see. Right, these are the 1 and the 2 length snake. Now, if the 5 was a 1 length snake, it would have to be a 5. And it can't be a 5, because there's a 5 in the row. So I think that means that's a 3. That's a 3, and that's a snake on its own. So this is a 2-cell snake, adding up to 5, not using a 3, so it's a 1 and a 4. And we're off and running, and we get another digit, look. These ones. I post a 1 there. Okay, I'm not sure if we can get... Can't see any more digits we can get, so... It's quite interesting, though. The 3-length snake is going to have to be a reasonably chunky sized snake, isn't it? The smallest next digit is 18. Although 21 could be a 3-length. So one of these is the 3-length snake. One of these 3 is the 4-length snake. Okay, so let's approach this the other way round, actually. Look, we've got a 41 and a 40 length snake. So we actually know that these are the 7 and the 8 length snake. How do we know that? Well, if we know that a snake of 9 cells would add to 45, and we do know that, then a snake of 41 or 40 is missing digits that sum up to 4 in this case, digits that sum up to 5 in this case. Well, you can't make 3 cells add up to 4, and you can't make 3 cells add up to 5. We just looked at that. So these 2 snakes here are missing a maximum of 2 cells out of the 9 cells, or 2 digits out of the 9 digits. So these must be of length 7 and 8. And we know the order, because this one has a 5 given. So if this was a snake of length 8, it would be missing a digit that's equal to 45 minus 40, which is 5. And it's definitely not missing that, because it has a 5 in it. So this snake is length 7, and this snake is length 8. Can I actually... Yeah, oh, no, I didn't want that. I wanted to put the 8 there. Well, I didn't want to put it there. I wanted to put it as a corner pencil mark to sort of... I'll just have to remember. The 41 is of length 8. The 40 is of length 7. Okay. Well, we know the 37 now. Because a 37 cannot be of length 5. Because the most I could make 5 digits add up to would be 5, 6, 7, 8, and 9, which only add up to 35. So this is a length 6 snake. So this one, and this one, I've used 6, 7, 8, are 5, 4, and 3. And actually, I think they could... Well, this can't be 3. But I think other than that, they could all be each of those lengths. Oh well, that's fine. At least we've narrowed down things a little bit. Now, how do we make further progress? We've got to... Well, this... I thought they had to be... Yeah, they do. They have to be L-shaped regions, don't they? So this... How does this one, which is sort of corralled into the corner here, make an L shape? It's going to have to come down this side of the grid. So this snake here has to do that. And that's interesting immediately, because it hits a 2. So this now can't be a length 4 snake, because a 4 length snake adding to 30 would be 6, 7, 8, and 9. So it must be at least 5, this one. Oh, and it can't be 6. I said another one was 6. Hang on, let's just fill that one in. Which one was 6? This one is 6. So this one is 5, exactly, and that means we know the value of these 3 squares, because these add up to 7, so these must add up to 23, and they are 6, 8, and 9. And there's a 6 here. So this is a 6, this is a 9, because of the 9 there, this is an 8. 4 by Sudoku goes here. 1 goes in one of those 2 cells, which means 1 is in one of these 2 cells. And the other digits we need are 3 and 7. So these are 1, 3, and 7, and that isn't 1. And we've got a snake. Right, let's colour these ones in different colours then. So this one can be green, that one can be red. The 40 is of length 7, isn't it? Right, okay, this is interesting. The 40 needs to bend somewhere. So it can't just take these cells. I mean, it's obviously not going to get to 40. It's got to come to this one. Now, in taking this cell, we now know what the composition of the 40 snake is, because it has a 4 in it, and it's missing 2 cells that sum to 5. So it's not missing 1 and 4, it's missing 2 and 3. And that means, look, it can't come across and take that cell. So in its journey across the grid, it's going to have to stop and turn down either there or there. Because it can't go that far. Oh no, it could just turn immediately actually, hang on. Oh yeah, so it has to turn there, there, or there. And it has to be of length 7. And does it take these or not? Or do we not know that yet? No, I don't think we do know that, because there are 2 regions of every size. So although I've got a 1 and a 2 region down here, I think there could be another 1 and 2. I think, in fact, there are another 1 and 2 cell region. So if this snake could just start here and go across, or it could pick up these cells, but I don't think we know which way what it does. Okay. Sorry, let me just stare at this for a second, and hopefully inspiration will strike. It's got to be a 1 in one of those. The 45 now can't come too far to the left, because if the 45 came to there, now the blue, the 40, is broken because it can never turn before it hits a 2 which can't go in it. So the 45... So if the 45 does come left, so it could come to there and turn. 1, 2, 3, 1, 2, 3, 4, 5, 6. Oh no, it can't do that. That's lovely. Look, if it does that, I think it hits that 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. It does, so it would have a 2 2s in it. So it doesn't do that. So if it comes this way, it can't come to there. It would have to turn here. That doesn't work. It can rule that out straight away as well, because you can't put a 4 in this 45 region because of the 4 at the top looking right down the column. So if this was like this, we know the 45 should have 1 of each digit. It can't have a 4, so that's not right. So if this, hang on. So if this comes this way, it can't turn downwards. Oh, bobbins. No, I was thinking that that must mean it comes down here, but it doesn't mean this is a corner, does it? All I've ruled out is that this is a terminus of the snake. This is a head or tail of this snake, and that it starts that way. So right, let's try and prove that this is a corner. So if this is not a corner, it would have to start down this way. We know it doesn't start and turn that way. So let's just work out. I don't think it's long enough to do that. That's only 8 cells. It needs to be 9. If it comes here and goes all the way to the end, it can't have a 9 in it. This is lovely. This is absolutely lovely. That's immediately ruled out. Although it's a 9-cell region, you can't put a 9 in it there. So that's not possible. That hits the 18 before it gets to size 9. That won't work. That hits the 21, I think, before it gets to size 9. Just, yeah, that's its 9th cell. It can't hit the 41. That's too short. 1, 2, 3. Yes, that is too short. That's... Hang on, if it turns left, doesn't it hit the 2? 1, 2, 3, 4, 5, 6, 7, 8, 9. It does hit the 2, but it could turn right, except it can't turn right because this region is broken. Why is it broken? What are you going to put in there? The answer is whatever you put in there. Let's make it an 8. You now can't put 8 in the green region, so that's not going to work. So the only, oh, whoopsie, go away. So the only thing I want to test now is whether it can come down to the bottom of the grid. So that would be 8 cells, and then it would have to either come this way or this way. And that doesn't work because it can't have a 5 in it. Oh, lovely. Now, look, this 5 here and this 5 here, pinch it. And you can't put a 5, even if it comes this way. Obviously, this 5 does the same. So this is just not a head or tail of the green snake. This is a corner, and that means we get to put those in. And that means we get to bring this one out one more. And that means... Yeah, this is very important, isn't it? Because now this is going to push this snake downwards, because this can't... It could take that cell, but it definitely can't take this square. So that if it took this square, 1, 2, 3, 4, it still needs to take 5 more down here. So it's definitely taking the 9, and it might be taking the bottom cell as well. Although it's not taking the bottom cell as well. Oh no, it's not taking the bottom cell as well because you can't put a 5 in it. You can't now put a 5 in this, so that it never takes this square. So I think this is now forced to be the shape of this 45 region. So that means the blue still hasn't turned. It's got to keep going, and it's got to turn there before it hits the 2. And it's got to... Right, okay, so what does that mean? Is that, have we actually... Oh, I've got to put a 5 in the green. This 5 here is still problematic for the green. The 5 has to go there. 5 is in one of those 3 squares by Sudoku. 4, 5. Still don't know whether it takes... Oh, hang on, no, it's missing... No, this could be a 1, 7 pair. Sorry, I'm getting confused now. Okay. No, hang on, there's still a problem with the blue. The blue hasn't got a 6 in it. And the blue is missing the 2 and the 3. It's not missing a 6. 1, 2, 3, 4, 5. Oh, this is superb. Look, you've got to put a 6 in the blue. And you can't even put it here because of this 6 there. So it's got to come down to this square. These can't be 6s. So it's got to take that square, and that makes it of size 7. 1, 2, 3, 4, 5, 6, 7. Which means this domino is it's just another colour. This is actually a different region. It can't be two one-cell regions, because that would give us 3 regions of size 1, and there are only 2. So now we've found both 2-cell regions. We've only found one cell region. We've got to put a 6 in the blue. We can't put a 2 in the blue, so that's got to be the 2. And the other digits we need to put in the blue are going to be 1, 7, 8 and 9. Well, that square's a naked single, then that's a 7. These are 1, 8 and 9. And this square is a 3. Wow, that is lovely. Now 2's by Sudoku go here. 2's are in one of those 2 cells. 3 is in one of these 2 cells. 3 is in one of these 2 cells. 4 is in one of these 2 squares. That gives us a 3-4 pair down here, look. Oh, the 9, of course. Why don't I just do the easy things first? That gives us a 1-8 pair and 3-4 pair. 9 is exactly in one position in box 5. It has to be there. So this is a 3. 3 goes in one of those 2 cells. 5 hasn't gone into... Oh, why have I got a 9 here and there's a 9 here? What am I doing? The answer is going completely crazy. Don't go crazy when you're solving puzzles. At least that led to a contradiction very quickly. Don't put 2 9s in box 5. Good grief. Let's pencil 9s down there instead. So, hang on, let's just take stock as well. What have we got here? I've got this one I've not done yet. This one, that's a 6-cell region. So it's got to come down. 1, 2, 3, 4. So it can't turn and take the 1 because that will only be a 5-cell region. So it's got to turn there, which means this is a 1-cell region, and that goes with the grey over there. So we've now got both 1-cell regions. The 37... the 37 is missing 3 cells that sum up to 8. 45 minus 37 is 8, so it's never got a 1 in it. You always need a 1 in a 3-cell sum to 8. So the 1 in this box goes there. That fixes the 1 and the 8. 8 goes in one of these squares. This 3 fixes the 3 and the 7. These 2 squares have got to be 3 and 4. Look, there's a 4 down here. We get the 4, we get the 3. These 2 squares are 6 and 7, I think. These squares, we might as well delete that and put the correct pencil marks in. 5, 8 and 9. That's not 9. And so far, this is really just a lovely puzzle. And it's not, thank goodness, I think Mark was being honest for once, and this is not monstrously hard. It could be famous last words. Oh, it could be famous last words, actually. I think I've broken it, have I? Oh, you are an idiot. Oh, I don't believe it. This down here. I can't do that because that domino's going to be left and I've used the two cell regions. Oh, and if I do that, I get a 1-cell region. Oh no. What on earth was wrong with that? I don't know what I did wrong. What? Oh, I know what I can do. I can put a 3-cell region in like that. Oh god, that is horrible. That was horrible. But I haven't broken it. you can do a 3-cell region like that. I think that's the only thing that will work, because you can't isolate cells in this portion of the grid because I've got no small snakes left to use. So I've got to not isolate, and a 3-cell cage does allow me to bend. And if I do that, I can get a snake out there. So that is a big relief. Now, what shall I use? What colour shall I use here? I'm going to use black. I used black yesterday, and it was very fortuitous. So this can be a black region. So this one here needs to come out. Probably doesn't need to come out that far. It needs to come out at least this far, because it needs to turn. This one, I should know what it's got in it, shouldn't I? Yeah, this is missing 3 cells that sum to 8, and it contains a 4. So it must have a 3 in it as well, which must go here by Sudoku, I think. Which is lovely, because that gets me the 2 and the 5. And the other digits that have got to be in here are 8 and 6, and we can see that we can actually place those as well. 6 and 8 go in. These 2 squares at the bottom of the grid are 4 and 7. 4 aligns in boxes 7 and 9, look. So we can ask the question, where do we put the 4 in row 7? Can't be there, can't be there. We know the 4 in box 8 is in one of these 2 places, and we need it to be in row 7. So that's 4, that's 3. Okay. The 4, yeah, look, we can get the 45. Actually, yeah, we can just use the 6 to, that's got to be a 6 at the bottom of the grid, because I've already put a 6 in the 45 region, so these cells can't be 6. I need a 6 in column 7, so it's got to be at the bottom of the grid. That 6 and that 6 interact and plonk a 6 into this cell. 6 lives in one of these 2 cells in box 7. Okay. What have I got left to use here? I've got the 41. That's an 8-cell region. I've got an 18 and a 21. So these are the 3 and 4 size regions, aren't they? Okay. Don't know if we can tell. I'm not sure. We're going to have to come back. I don't think I know which way round these go. Apologies if I'm missing something there. 4, look. 4s. Got to be a 4 in one of these 2 cells. These 2 squares have got to be 7 and 8. That means this square is known. That is now a 1. 1, no. I'm not sure I do know about the 1s. 3s. 3 goes... Oh, 3 goes in the 21 cage. 3 goes here by Sudoku. 3 in the 21 cage is actually very useful, because now this can't be a 3-cell region, because if it was a 3-cell region, the other 2 squares would need to add up to 18, where they would have to be double 9, which I can't use in the same cage. So this one is now a 4-cell region, and this one is a 3-cell region. Oh, lovely. We know a 3-cell region still needs to bend in this puzzle. How can we do that? It's got a 2 in it. It needs to have a 16 in 2 cells, so it needs a 9 and a 7. If it takes that 9, it can't bend. It can get a 7 here, but it would be straight. It wouldn't be a bent snake. So it needs to find 7s and 9s over this side of the grid. Well, if this is a 7, you can't obviously put a 9 next to it because the 9's here, so it must go down and that way. And that not only gets us the 7, it also gets us the 4 and the 7 and the 8. This is a snake, so let's fill that in. We'll make that one purple. Oh no, I meant to make it black, I think. So in here we need 5. That's got to go there, and we need 1 and 8. 5 has got to be, this 4 is fixing this square. This is a 2. These are a 5-8 pair. So these two squares are a 6-7 pair. Much like we've now got a 6-7 deadly pattern that hopefully will be disambiguated by snakes. By Sudoku, this square is a 5 or a 9. It can't be an 8 because of the 8 there. Still not got this. This is an 8-cell region, isn't it? So, we can ask a sensible question about this though, and that question is: does this 41 region go upwards or not? Now, if it doesn't, let's imagine it goes over here somehow. I don't even know if it can do that, actually. Oh, maybe it could do that. But let's imagine it goes over like that somehow. What are we left with? We're left with this sort of 9-shaped region, or Q-shaped region, of size 7. Well, how on earth are we going to fill this with snakes that bend, given that we haven't got available any 1s, 2s or 3s left? I think we've got a 4 left. But if I put a 4 in here, the other snake will axiomatically be smaller than size 4, and I haven't got any snakes of that size that I can use. Obviously, I can't put a 7 snake in there because it'll have to bend twice. So the 41, I think we can say, must come up here. And just as it can't be left with a 7-cell region, it can't be left with a... I think this has to come to here and leave a 4-cell region. Because we have to leave enough room for a bending snake. So yeah, this is the only thing that will fit the bill there. This is a snake. Let's make that purple. Now the 41 is an 8-cell snake, so it has no 4 in it. So it can't now bend here because it will hit that 4. So it must come down and bend here. 1, 2, 3, 4, 5, 6, 7, 8. Oh no, that's not going to... Oh, have I broken it again? Oh no, I know what I've got to do. I was thinking this has to do this, and it could have done that perhaps, except it would have a repeat of 3 in it. But this one down at the bottom would be fenced in and couldn't turn. So I think what we actually do is connect these two up to each other. And I think 2, 3, 4, 5, 6, 7, 8. Perfect. So this is the 8-cell snake. And it's not got a 4 in it. Now, what does that mean? So it still needs 1, 7, 8 and 9 into these squares. That can't be 1 or 8. That can't be 9. Yeah, okay, and obviously by Sudoku, this square is a 1 or an 8. Whatever this is must be mirrored here. Okay. Okay, so now we get stuck, do we? Probably is the answer. Let's have a look down this column. We've not placed 5, 6, 7 and 8. So this square is a 5 or a 7 by Sudoku. That one is a 7 or an 8 by Sudoku. 7, 8. This square is a naked single, isn't it? Doesn't that have to be a 2? It does have to be a 2. Sorry, that's been available for a while, I think. Where does 9 go? Yeah, hang on. Where does 9 go in this box here? It's got to go in the corner. That 9 gives us a 7 there. This square now has to be a 5. That gives us an 8 at the top, which gives us a 7 down here. That gives us a 9 and a 5 here, a 5 and an 8 here. These squares are 6 and 8. We've got an 8 up there. 8 and 6 go in the grid. This 8 gives us a 1, an 8, an 8 and a 9. The 7 fixes the 7 and the 4. The 4 fixes the 4 and the 1. This is very cool, actually, because we're left with a deadly pattern, but we have by no means finished the snake part of this problem. We've got to use the snakes to finish off the Sudoku, which is obviously very nearly done, but the snake part is not done at all. So this 21 is a 4-cell region adding up to 21. And it's got to bend. It's got to bend. So a quick scan of the grid makes me quite worried about this. How do we actually get high enough to make this work? That is high enough, but it's too high. That's 22. That's not high enough. That's too high. That maybe that. Look, no, that's too high as well. Oh, that works. That one works. I think that's the only one. It's the only one I've found that works. If you don't take the 9, that 9 isn't big enough. That's too big. That's not big. Yeah. Basically, by observation, this is the only way of getting this to equal 21, which we can make red, therefore. So now I've used 2 snakes of size 1, 2 of size 2, 2 of size 3, 2 of size 4. I think I've only used 1 of size 5, 1 of size 6, 1 of size 7, 1 of size 8, and 1 of size 9, but there is only 1 of size 9. So I need to put 5, 6, 7, and 8 in here, which is 26 cells. 12, 13, 14, 15, 16, 17, 18, 19, 20. 26 cells, right, so we are on track. Well, this square is very interesting immediately, because if that snake does that, these 3 at the bottom are broken. So it can't do that. It's got to be a 5-cell snake that bends round the corner there. So we actually can do that straight away. That's not repeating a digit in the snake, so that looks good. This snake now has to be at least size 6 because we've just used the 5 snake. So it's got to do that and take 1 more. And that's beautiful. Look, that disambiguates the 6 and the 7. This 6 is going to repeat if that's a 6. So this is 7. This is 6, this is 7, this is 6, and we have to go at least to there. I will make this one blue, I think. Now, if it stops there, the puzzle's broken, isn't it? Because I've now got to fill these 15 squares with a snake of size 7 and size 8, and there's no way to do that with it bending only once. It's just too much real estate here, so it's got to go up again. No, this still is no good. The way this will have to work is we're going to have to bend a snake. If we go up 1 more, we can do it, because we can bend the snake like this for 1 snake. Let's make that one grey. And then we can bend this snake round like that, and I think that is the correct solution. And let's just check. We've now got 1, 2, 3, 4, 5, 6, 7, 8. We've got an 8. That must be 7, and it is, and that's a 6, and that is how to solve the puzzle. What a beautiful puzzle that is. Not overly complicated. I mean, it's still taken me nearly 40 minutes, but Loved every minute of it. I hope you guys did too. I hope you tried it. Let me know in the comments how you got on. I do read them. And thanks so much for watching. We'll be back later with another edition of Cracking the Cryptic.